In this video, we move on to section 3.2, which is all about trigonometric integrals. In this section, we look at how to integrate a variety of products of trig functions. So when you're integrating products and powers of sine and cosine. So a key strategy involves rewrite them in the form the integral of sine to the jth power of x times cosine of x dx, or cosine to the jth power of x sine x dx. Right, so the key to notice here is that only one of them is raised to a power. So notice that only one of them, right, the sine or the cosine, has a power. So that is the key strategy in this section, is for only one of the trig functions to be raised to a power. So, for example, let's say we were given this integral. Evaluate the integral of cosine to the third power of x times sine of x dx. So this is already in the format we need it to be in. Already only one of the trig functions is raised to a power. Right, therefore there's no rewriting we need to do. We can go right ahead and use, what technique would we use for this? Well, we know the derivative of cosine is sine, so we can use a u-substitution with u as cosine and then du as sine x. Right, that's negative sine x dx. Derivative of cosine is negative sine, so negative du is sine x dx. So we plug that all in, and this becomes u to the third power times negative du. You can pull out the negative one that's being multiplied there, and that's just u cubed du. And then remember, for the powers, we add 1 and divide by the new exponent, and we need a plus c here because we don't have bounds. So this becomes negative u was what? U was cosine to the 4x over 4 plus c. And that's our answer. So let's do another example. Well, before we get into that, we're going to talk about what if. So what if it wasn't in the only one raised to a power format? Right, so then we're going to have to rewrite using trig identities. So let's talk about a problem solving strategy. So to integrate the integral of cosine raised to some power j to the x times sine raised to some power k of x, right, we're going to have to, you need to look at if the powers are even or odd. So if both powers j and k are even, then we're going to use either sine squared x is 1/2 minus 1/2 cosine 2x, and sine, it should be cosine squared x is 1/2 plus 1/2 cosine 2x. So that's if they're both even. Now, if one or both are odd, okay, so if one or both are odd, you're going to use the trig identity cosine squared x plus sine squared x is 1 on one of them, and then use u-substitution. So these are the general rules that we will use. So let's do an example. So let's say we were given this example that says evaluate the integral of cosine squared x times sine cubed of x dx. So clearly we see, right, that we have sine raised to the power of 3, so that is an odd power. So that means that we need to use this trig identity here. Okay, so the first thing is that we need to rewrite this integral in the form cosine j of x times sine of x dx, right? Where only one of them has a power. That's our goal in order to be able to evaluate it. So notice that, right, the first thing we can do is make sine cubed of x be sine squared of x times sine of x. And like we said, we need to use the trig identity. Cosine squared of x plus sine squared of x is 1. So we know that sine squared of x is 1 minus cosine squared of x. Right, so then we take both of these in our original integral, which was cosine squared x times sine cubed of x dx, and then we're going to make that equal cosine squared of x times sine squared of x times sine of x dx. And then we know we can replace the sine squared with 1 minus cosine squared of x and bring everything else down. So then now we want to use u-substitution. Remember, that's the next step after you use your integration by parts. So we're going to we see that cosine is the one that's being plugged in, right, because it's squared. So cosine of x, and then du, remember derivative of cosine is negative sine of x dx. So this becomes u squared times 1 minus u squared times minus du. Right, so we can take the minus sign out, and then we can do u squared times 1 minus u squared du. And we don't have an integration formula for that, but what we can do is simplify this by distributing the u squared, and so then that becomes the integral of u squared minus u to the 4 du. Right, and now we can use the power rule on both, so we have this negative sign out here. This becomes u cubed over 3 minus u to the 5 over 5, and then we have our plus c, and then we can distribute the negative sign, so that becomes negative u cubed over 3 plus u 5 over 5 plus c, and then now we just need to plug back in u, which was cosine, so this is negative cosine cubed x over 3 plus cosine to the 5th x over 5 plus c, and that is our final answer. In the next video, I'll do more examples, and you can also find more examples in the textbook notes. More examples in the textbook notes on Canvas.